Hello, good morning everyone. So today we are going to look at the continuation of integration for infinite integral. So we're going to look at improper integrals. Now, for my previous lesson, I've given you three definitions of integration over an infinite interval. Okay, so we're going to look at that more now. So let's consider you have the first axis, something like this. Okay, so this is from 0. Let's say you have an interval from A to, and this is X. So let's say this is my B here, somewhere here. Okay, so this is my Y value, okay? And this is my curve here. So you want to find the area under this curve, right? Because you're finding integration. Integration is finding the area under the curve. Okay, this is when n approach infinity. So we don't know where the x goes, but this is a graph of y equals to fx. Okay, so this figure here say that fx continuous on the interval from a to infinity. Okay, this is the first figure here. So when you want to find the improper integral, if you're given this type of interval here, so to find the integration from a to infinity, fx dx, it simply means you apply the limit as t approach infinity from a to t fx dx, and provided the limit exists and is finite, okay, then it's finite. Now the second type here that we can look at is when you have a continuous interval. Okay, when you have a continuous interval where, but from negative infinity to, let's say, b. Okay, so the graph will be something like this. It's y, this is x, so this is a b here, and let's say I want to uh, find the area under the curve for this part here. Okay, so what happened now? This is 0 here, right? So this is negative infinity when n approach negative infinity. So for this graph here, we want to say that fx is continuous on the interval from minus infinity to b. Okay, now to solve this kind of integral, so you want to find from minus infinity to b fx dx. So simply mean you apply the limit as t, not x, as oops, I'm using the wrong one. I think I should use this one. Okay, so simply means from t approach negative infinity t to b fx dx. Okay, so this is case number 2. Now the third case will be if you are given a function which is continuous on some number c. Let's say something like this. Okay, this is my c, this is 0. Now let's say these are all the area under the curve that you want to find, and this is minus infinity as n approach minus infinity. This is as goes to positive infinity. And this is my graph y equals to fx. So for this case here, the integral is from negative infinity to infinity fx dx. Simply mean you split it into two. So one is from negative infinity to c. So this part here, okay, I'm just gonna shade it. Not quite the same, but okay, this part here plus from here now. Okay, from c to infinity. That's how you get this whole region here. So c to infinity fx dx. Okay, so these are three cases where the limit for improper integral take place. Okay, and you say the solution convergent if the limit is finite and divergent if the limit does not exist. So let's look at one example where the case is case C. Case C, okay, so look at one example here. Okay, so what this example says, okay, the example say that determine if the given integral is convergent or divergent. Okay, that's the first point here. Find the value. Find its value. Okay, given from minus infinity to 0, 1 over square root 3 minus x dx. Okay, so let's look at this question given here. So the first part, it says that find if it's convergent. Right? Convergent means you must have a finite value. Okay? Divergent means the limit does not exist. No matter what you try, even after you apply L'Hopital rule and things like that, the limit does not exist. So divergent. Okay? So look at the given integral here. So it's given from minus infinity to 0, which falls on the second case here. So you have to apply this definition. Okay, case number 2, to solve this given integral. Okay, so we can do that easily, right? So limit from minus infinity to 0, 1 over square root 3 minus x dx simply means you apply limit as t approach minus infinity. Okay, now look at the definition. You're looking at this one here. T to b. Now b is 0. B is 0. Okay, this is my b here. This is my b. This is my b limit. So t to 0, 1 over square root 3 minus x dx. Okay, so I can solve this once I solve this integral over here. Now, how do I find this limit? So, to solve this integral here, it is better, easier if you can write it something like this. 3 minus x negative half dx. Okay, it's much easier to write it like this. Now, you can apply chain rule here for inside, right? But I'm going to do it directly because this is not difficult to solve this integral. Okay, when I'm applying when I'm finding the integral, I don't have to write the integrand t to 0. So this is t to 0. Okay, so what happened here? Negative half plus 1 will be 1 over 2, right? So I will write 3 minus x plus 1, meaning half, divide by half. I hope you're with me. And then look at the inside bracket here. Take the derivative for negative x. Will give you minus 1. Okay, negative 1. There you go. Now continuing, I can simplify this. Okay, so I will have 2, negative 2 half in your denominator. Bring it to your numerator, will be minus 2. 3 minus x half. Okay, we are good to apply the limit now. Okay, so what happened when when x equals to 0, I have minus 2, 3 minus 0 half minus when x equals to t. Gotta be careful with so many positive and negative appearing. Just put a big bracket here. Okay, so first you apply the limit when x is 0 over here, and then minus when x is t. Okay, now simplifying, what happened next is you simplify this. I have negative 2 square root 3, negative will be positive 2 square root 3 minus t. Okay, this is what you get. Now what you gotta do here, you apply the limit when t approach negative infinity. So let's look at this term here. Okay, there's no t term here, right? So I can bring this out, or limit for this one will give me negative 2 square root 3 plus, now limit t approach infinity. So I'll have a square root something like this. 3 minus negative infinity, okay? Now, I don't recommend you to write this, but this is just for your understanding. So 3 minus a very large number. What happened when you minus a very large number? That will leave you to a very large number, right? So this whole term here is infinity. So it will be 3 plus infinity. Now square root over infinity times by 2 or whatever is still infinity. Now something small plus infinity, that will give you with the answer infinity. So this is equals to infinity. Okay, now what the question said here, determine if the given integral is convergent or divergent. So from the solution, you are not getting a finite solution. So the limit is infinite. So the integral is divergent. Okay, as simple as that. Okay, you solve the problem. If you don't get a finite number, it means it's divergent. Okay, now if you look at all this graph that I've plotted showing you the 3 cases, these are all continuous function. I mean, my f is continuous. This is also, f is continuous. Look at the curve here. It's continuous, right? There is no discontinuity occurs in any of this graph. They are all continuous function. So how if you are given an integral with infinite discontinuity? Meaning there is a discontinuity occurs at a certain value of x. So we're going to look at that example now, and how are we going to solve that kind of function in our next video.